Okay, here we go. 4.3, proportional relationships and graphs. So last time we talked about proportional relationships have a constant, how it looks in a table, and that we can write an equation. But this time we're going to use graphs to represent and analyze proportional relationships. So no tables. You might use one to make a graph, but we're going to be looking at the graphs of proportional relationships this time. So our two terms for today is an ordered pair. That's the x and y values on a graph. Remember that x always comes first and then y on a graph. Also remember that the x is the part that goes left and right, and the y is the part that goes up and down. Okay, and then the origin is the point 0, 0 on a graph. Okay, it's right in that middle. Right? When we look at a graph, it's this one right here, 0, 0. So a proportional relationship, when it is graphed, it is going to be a straight line, has to be a straight line, and it has to go through the origin. Okay, if it does not go through the origin, then it cannot be proportional, and if it is not straight, then it cannot be proportional. So you can see the first one is proportional because it is straight and it goes through the origin. And that's what we mean goes through the origin. The point 0, 0 is a part of the graph. So the second one is not proportional. It does go through 0, 0, but if you notice, it is not straight. So that's why it is not proportional. And then the third one is not proportional because if you notice, it does not go through the origin, right? So not through the origin. It is straight, but it has to go through the origin. So that's what makes this one not proportional. It has to have both things happen. Okay, so that's why the first one's the only one that's proportional because it goes through the origin and straight. Not proportional because it's not straight, and it's not proportional because it's not through the origin. So if you can say not for one of those, not straight or not through the origin, then it's not proportional. So in our first example, we have a house cleaning company charges $45 an hour. Is this relationship a proportional relationship? So we are going to make a table, but we're not going to use the table to find the constant. We're just going to make a table. So in 1 hour, it's going to cost me $45. So 2 hours, it would cost me $90. 3 hours would cost me $135. So to find $5, I can just, or 5 hours, I can do 45 times 5, so 25, and then 22, so $225. And to get 8, I would just multiply by 8, so 40, and then 32, so 36, so $360. So what you've also just done is created ordered pairs. These are all individual ordered pairs. So we can use them to then make a graph. Okay, so these are ordered pairs. This is the 0.145 and 290, 3, 135, because remember this one's X, this one's Y, so on. And I'm going to put the last one down here. So we're going to do our best to fit these on the table. So 145, right? This one's 50, so it's pretty close to there. And then 290 is just under 100. And 3, 135, and so on. So we're just going to do our best to add these on here. Okay. So remember, we need to check that it's straight. Okay, now we did have to kind of sort of estimate it, but it is pretty straight. And would this go through the origin? Well, if I think about it, if I had 0 hours, I would then, of course, pay $0. So it does go through the origin. So is this relationship proportional? Yes, it is proportional. So since it is proportional, it means there has to be a constant rate of change. So we could set up all of these ratios, 45 over 1 and 90 over 2, which is also 45, and 135 over 3, which gets me 45. And so we would get this constant. Remember, the constant is k of 45, and so our equation would be y equals 45x. Okay, so here's the additional practice. The graph shows the relationship between time in minutes and the number of miles Damien runs. It wants you to write an equation for this relationship. So you would first need to determine if it is straight and goes to the origin. Okay, so we could connect these and see that it is straight, and then we can just continue it back and see that it does in fact go through the origin. Also, if we think about it, minutes and miles, because this is y, right? Remember, that's the up down, and this is x because that's the left to right. So there's my x and y. If I have not started my run, right, no time, I have not done any miles. So it does in fact go through the origin. So what that tells me is this is proportional, so I need to find the constant. So I would look at these points that I have. I have 10, 1, and I have 22, and we've got 25, 2.5, and 30, and 3. So with these points, I can set up those ratios, 1 over 10, 2 over 20, that reduces to 1 over 10, 2.5 over 25 will also reduce to 1 over 10. And we've got our last one, 3 over 30 will reduce to 1 over 10. So I have found my k, my constant, it's 1/10. And since that's my constant, it was straight and goes to the origin. We can write our equation of y equals 1/10 x. Okay, I can only write this equation because I know it's proportional. If it's not proportional, we can't write this equation because this is for a proportional relationship. So the graph shows the relationship between the distance a bicyclist travels and the time in hours. Okay, so remember this is x, this is y. So it says, what does the point 460 represent? So since this is time, right, there's x and y. Time is x, so 4 would be 4 hours, travels 60 miles. Oh, can't spell the word miles, apparently. Miles. So that's what that point represents, that in 4 hours they travel 60 miles because x is hours and y is miles. So what's the constant of proportionality? Well, I need to first make sure this is straight and that it goes to the origin. Okay, prove that it's proportional. So then I would use my points, right? I'm not going to really use this one. Do you see how I have to estimate it? That's not a good point to use. at this point, since I know it's proportional, I can use any points I want to. So I'm actually going to use 2 and 30, which gets me a ratio of 30 over 2, which is 15. And then I'm going to use 40 and 60, or 4 and 60, sorry, because that's directly on this corner. I don't want to use this one. See how it's an estimate, right? We know it's 3, but we're not really sure what it's over here, so it's best not to use it. But since 4 is right on this corner and I don't have to estimate it, it's the best one to use. So I'm going to go 60 over 4, and I'm going to also get 15. And then I can use this last one of 6 and 90. So 90 over 6. And I would, in fact, also get 15. So there's my K. So what is their constant? K equals 15. And so we can write our equation, y equals 15x. So things to remember. Remember, the y is the up, down. The x is the left, right. Okay, the points are always written as x and y. And that a proportional relationship must be straight and go through the origin. It cannot be one or the other. Must. All right, so here's your independent practice. Answer that question and we'll talk about it in class. See you next time.